An atom's electronegativity. When atoms are in a covalent bond, the electrons are shared, but they're not shared evenly. One atom is going to hog the electrons in the bond, and those electrons are going to spend more time closer to that atom there. I'm going to draw some pictures to try to show that. Okay, let's consider a carbon and oxygen bond. Now, this is a sigma bond with a pair of electrons in between them there. To draw the electrons, say, identical in distance or right in the middle between them, wouldn't reflect the higher electronegativity of oxygen. Still showing a sigma bond, but the electrons are pulled closer to the oxygen atom. This does weaken the bond a little bit here. If we had oxygen and fluorine, if we were to draw a single bond in between them, I'll draw this in a different way. I'll draw with a line right here. So again, we have a line that's meant to represent a bond. Now this line is even in thickness, but that would not reflect the electronegativity. Fluorine has a higher electronegativity than oxygen, so I'm going to draw it like this. And this is a very cartoonish image of imagination to try to get you to think of that sigma bond of two electrons, fluorine's higher electronegativity in this cartoon here. There is a pattern of electronegativity in the periodic table, and let's identify that and talk about some examples. Now, before we look at the pattern of electronegativity in the periodic table, we do need to make a little bit of adjustment here. For this pattern to really hold up, hydrogen, the box of hydrogen, it really should be right above carbon, because hydrogen and carbon have very similar electronegativities. And for most of Gen Chem and OChem, knowing that they have very similar electronegativities is very important. The trend of electronegativity, if you move up on the periodic table, it is going to pull more or have a larger electronegativity value. So atoms, if you're comparing atoms that are in the same column, the one that is further up is going to have a higher electronegativity. When moving to the right on the periodic table, atoms increase in electronegativity. So for example, if you have atoms that are in the same row, you would pick the one that's further to the right having the higher or larger electronegativity. A lot of electronegativity trends and periodic table trends and values don't include the noble gases. And that's mostly because the noble gases don't participate in covalent bonds very well. And for most of Gen Chem, we don't think about the noble gases too much, except we're talking about gases here. Now, some examples of comparing electronegativities or prediction right there. So for example, some atoms, such as carbon, nitrogen, if we were comparing nitrogen and say sodium, which of these would have a higher electronegativity value? We would predict that nitrogen would have a higher electronegativity value because it is further to, they're in the same row, and it's further to the right on the periodic table there. Carbonate. What about oxygen and selenium? So oxygen and selenium are in the same column. We would predict that oxygen has a higher electronegativity and would pull electrons closer to itself when in a bond compared to selenium. Thank you.